So, longtime viewers of this channel know that I like to tinker with 3D printed RC models, and it should be no surprise that I have another one to show you. However, this time I also have a new type of filament to try out, and it's this. It's called LW-PLA, and it comes from a company called colorFabb, which I'll put a link in the description below. It claims to be significantly lighter than regular PLA, yet pretty much as strong. So I finally got my hands on some, and I'm really looking forward to experimenting with it. And also I've got a new model from Eclipson Aircraft to try out, and it's called the Panthera, which is a new high-speed civilian aircraft being developed by the Pipistrel company. So it's a new model, and I'm actually building the prototype for the company. So we are going to head first into uncharted territory with a new filament and brand new model design. So let's get started. First off, the main changes to the slicer for LW-PLA is to reduce both retraction distance and extrusion multiplier settings, as the LW-PLA is extruded at roughly half the rate as regular PLA. Okay, after experimenting with the settings and finding all the bad settings apparently, I think I've homed in on what seems to be working. I mentioned the bad settings. This is kind of what happens when you have too much retraction. It started out okay, and then it started breaking apart. It started clogging up and basically, I guess, stripping. When you don't have it's the stuff is they said you can't use much retraction, and it's true, you really can't. And so I thought, well, I try to see how much retraction can I use before it breaks, and I found out. So I think I've got the settings tweaked pretty good, and I'm running along printing all the parts. It's going to take a while, of course. I'm printing at 0.2 millimeters resolution, so it's going to take a while. But it's just press a button, go walk away, have a sandwich, play a video game or something like that, or work on another video or something like that. But anyways, there's a reason why I was experimenting with the retractions, because I was warned that this particular type of filament is very stringy, and it is very stringy. Here's a piece I actually did print out, and like I said, it came out pretty nice. Like I mentioned before, I think the surface comes out really nice, but you look in it and it is really, I'm probably not going to focus very well. There we go. This looks like a mess, but apparently this is normal. So if you're OCD on the interior of your aircraft, then maybe this is not the filament for you. But again, this is not something you're going to see normally. It's all going to get covered up, and it's just the way it is. But hey, all in the name of science, right? So I'm looking forward to really getting all the rest of the pieces printed out. I do have some cleaning up to do. I see some little surface aberrations here, but it looks like, and for the most part, it's pretty good. Strength looks really good stuff, and the stuff is light. So I am moving along with trepidation and see how the rest of the pieces go. So to compare weights, I printed a part in normal PLA, which was 2.1 ounces. Next was the same part printed with NetFab's LW-PLA. Wow, almost half the weight at 1.2 ounces. Before gluing on some of the parts, you may need to clean up some of the stringing with a knife. The Panthera uses carbon rods of different sizes for reinforcement. It's a good idea to sand the edges in order to make the rods easier to insert into the wing slots. Medium CA works just as well with LW-PLA as with regular PLA. For rods that are too long, I trimmed them with a rotary tool and sanded the edges. Continue to assemble the rest of the wing in the same manner. Hey, now we're getting somewhere. Okay, so I made my first error, you could say. As the famous quote says, mistakes were made. So I'm going in to install the ailerons, The ailerons are multi-segment, which is pretty interesting. So we have a segment here and so forth, and it uses a 2mm rod as the hinge point. So I said, okay, that's pretty neat, except for one thing. I really should not have glued on the wingtips to do that, as I now have no way of inserting the rod. Ideally, you would, I suppose, insert the rod through and then put the wingtip on. I can't go this way because this is already on and it's a stopper in there. So I'm going to have to find out a way to either remove this wingtip, which is glued on and it's really not going anywhere, or maybe poke a hole through the tip or something like that, which I think I might try to do first. So let's see how I'm going to solve this issue to getting tab A into slot B. I decided to use a piece of music wire with an angle cut by wire cutters, which I slid through the pivot joints and poked through the wing tips. Then I slid the 2mm carbon rod in reverse direction through the aileron pieces. Heh, work like a charm. I love it when a plan comes together. Lastly, I glue the segments together. Some pieces may need a brim for better bed adhesion, which should be trimmed down with a knife and sandpaper. Then you just rack and stack the fuse pieces with glue and a little kicker to speed things up a bit. Before joining the front half of the fuselage, insert the carbon rods into the respective slots. This is essential for stiffening the tail. It's not critical if the rods are not long enough to reach the nose as long as the tail is supported, though I did use an additional short rod for the top of the fuselage. Now I glued on the vertical tail. Then use the printed pivots to mount the rudder. Just a touch of glue to keep the pivot hinge in place. The horizontal assembly is pretty clever. 2 core pieces are glued onto the tail. Then use carbon rods as the elevator hinges. A small centerpiece served as the control horn. All 3 pieces are then glued together. Lastly, glue the tips on. Trim the rods if necessary. Back to the wings. Install the pushrod connector. A dab of super glue keeps the nuts on. After opening the hole a bit for the control rods, install the aileron servo into the servo tray. Slide everything into position and screw into place. The tail controls are done in a similar fashion, but with 2 servos on 1 plate. I found the elevator control rod was a bit stiff at the required angle, so I made a slight bend with pliers. Much better. A simple and direct setup. Next we attach the motor to the motor mount. Then insert and attach the whole assembly into the fuselage. I found some nice button head screws for the job. The nose gear is in multiple pieces and must be glued together. The fit was slightly tight on the pivot block, which was not surprising due to the glue seam. so I engaged the services of Mr. File. Yes, much better. Thank you, Mr. File. The nose gear block itself fits into the fuselage quite nicely, with a couple of screws to hold it into place. I use a short piece of music wire to lock the steering wheel lever into place. The steering servo can be mounted to either side of the fuselage. Finishing up on the undercarriage, the pivot pin didn't fit, so I opened up the hole with a drill bit. The tires are printed with TPU flexible filament. This is neat stuff which I enjoy using. Printed at about 20% infill and it will easily snap onto the wheel hub. 2mm bolts are used as axles. Small hairbands are used as tensions for the shock absorbing gear. Like the nose gear, the mains use an insertable block. This allows parts to be reusable in the event of a crash. The fit was a little loose, so I glued the legs into place. These little discs are used to hold on the wings. They hold 3mm nuts into place when you glue them onto the fuselage. 3 long screws are used to secure the wing. Time to finish off with hooking up the nose gear. Install the speed controller and receiver, which finishes off the electronics. The model files include a printable spinner. Let's hope I can use it, as it looks really nice. One last detail is the exhaust port, which is a separate piece. All right, she's ready to go. I'm glad that I've got it all put together, and I'm really excited to get this thing up in the air. I did a quick weight test, and it comes out at right around 27 or so ounces, and a rough calculation puts that at right about 16 ounces a square foot of wing loading, which is actually really good. That's pretty light. So this LW-PLA looks like it's going to be the bomb. Okay, I shouldn't use those slings. Anyways, so nothing left to do. I'm going to just double check the control throws with the what they recommend, and triple check the CG. Looks like I'm close to it with the battery pack I want to use, but it gives me some leeway. So looks like there's no problem meeting the CG on this, which is really good. So I guess a nice long nose moment makes it easy to move the battery pack around, that kind of stuff. So I'm going to end the video with that, where the next one will be me flying it. And oh well, I guess I'll need to kind of dress it up a little bit. It needs a, I think I'll put a little bit of paint on it to at least put some windows, make it look like something, and maybe go a little further than that, but we'll see. But one last thing I want to mention is that the Eclipson-Aircraft says, hey, you know what, people who watch this video, if they use a discount code of HobbyView, they can actually get a discount off of the STL files. So I'll put more details in the comment section or in the information section, so look down there and you'll see the links to where you get the file, and stay tuned for when I do part 2 and we will fly this little baby, huh? Yeah. I just love these gears.